So, what we discussed in our last session? Anyone?
So recursion tail and head method is there, and after that we have discussed.
So, we have seen what is mean by recursion. So, what is the purpose of stack inside the recursive calls? And even we discussed three different cases in recursion, right? So, like finite recursion, infinite recursion. So, next and after that, what is another one? Direct recursion, indirect recursion, next tail recursion, non-tail recursion. These things I covered very clearly, even with examples also. Then, in which areas we are oftenly using this recursion, I explained. So, next and after that, even the recursion versus iteration process also I demonstrated. And we started implementing algorithms also, applications also. As a part of this, we have seen the first application, like how you can print the content of the string in forward direction, and how we can print the content of the string one by one in reverse direction. So next, how to find sum of n natural numbers, product of n natural numbers also we discussed. Okay, so today we will take few more examples, around some uh, 4 or 5 examples we will cover. Can I start? Please confirm.
Yes, sir.
Now, sir, I want to write a program to find nth Fibonacci sequence. I want to write a program to find nth Fibonacci sequence. Sir, nth Fibonacci sequence. We know what is mean by Fibonacci, right? So what is mean by Fibonacci sequence? If we are taking the numbers, like first number as a 0, second number as a 1, sum of these two terms is nothing but 1. So every number in Fibonacci sequence is sum of previous two numbers. So 0 plus 1, 1. 1 plus 1, 2. Now 2 plus 1, 3. 3 plus 2, 5. 5 plus 3, 8. Like that, every number is sum of previous two numbers. Assume this is 0th number, this is first number, second, third, fourth, fifth, sixth. Like that we have. So if you take any function with the number n, what is the formula? F of n minus 1 plus f of n minus 2. Sum of previous two numbers is the Fibonacci. Suppose if you pass n is equal to 4. What is the fourth Fibonacci number? 3. If you pass n is equal to 6, what is the sixth Fibonacci? 8. Like that, we have to write a program. The program is very simple. First, I will explain that state space tree diagram. Then we will go for a program. Are you clear? Please confirm. Clear, friends?
Yeah.
So let us take the program. Sir, system.out.println of I want to find FIB of something like fifth Fibonacci number or sixth Fibonacci number. What is the code here? Sir, if you are taking f of, okay, let us consider. I am taking, so f of fourth Fibonacci number I want. I told it is sum of previous two numbers. What is the previous number? Means 4 minus 1, which is nothing but 3. It's a previous number, 4 minus 2, 2. And this one again, so 3 minus 1, which is nothing but 2. So 3 minus 2. which is nothing but 1. This one, 2 minus 1, which is nothing but 1. So 2 minus 2, which is nothing but 0. And this one, 2 minus 1, which is nothing but 1. 2 minus 2, which is nothing but 0. So we have to divide until you are getting either 0 or 1. So when you got 1, what is the first Fibonacci number? 1. If you have got 0, what is 0th Fibonacci number? 0. So 0 plus 1, result is 1. And for first Fibonacci number, it is 1. So 1 plus 1, it will return 2. And here also, first Fibonacci number is 1. 0th Fibonacci number is 0. So 1 plus 0 will become 1. So 2 plus 1. So fourth Fibonacci number is 3. So you have to stop the process whenever the number is either 0 or 1. Can I say it is a base case? Yes. If you are clear with the state space tree diagram, I will write the code. Clear? Yes, please confirm. So let us take a function FIB taking one input. So what is the base case? If the number is equal to 0 or if the number is equal to 1, we have to return the number. Otherwise, we have to take FIB of n minus 1 plus FIB of n minus 2. So first number plus the second number sum. And here I am going to take FIB of I followed by some space. What is I there? For integer I is equal to 0, I less than or equal to 10, I plus plus. So we are going to calculate 10 Fibonacci sequences. Are you seeing? So 0, 1, 0 plus 1, we got 1. So 0 plus 1 plus 1, 2. So 1 plus 2, 3, 2 plus 3, 5, 3 plus 2, sorry, 3 plus 5, 8. Like that, we are generating Fibonacci sequence. Any questions?
So, so you have given a term that is best case. What is that, sir?
Mhm. What is your question?
Sir, you have given a terminology. You have used that best case. So what is that best case was?
Best case means what? I have not covered it right. Best case means what? The number which is there at the very beginning is called as a best case. Suppose if I have stored these values in an array, like 100 numbers I generated and stored in an array. When you are searching for the data, then only complexity will come into the picture. Otherwise, complexity won't come, right? So what is the time complexity for this? Big O of n. What value you are giving, based on that only number of comparisons will be there. Got it? Please respond.
No, sir. Once more, sir. I didn't got that.
Sir, here best case is not an issue. Why best case will come here? What kind of operation we are doing? We are calculating some value. That's all right. For that calculation, where best case will come? No. Suppose if n is equal to 0 or n is equal to 1, that is the best case because immediately you will get the result without dividing the problem. Okay?
Okay, sir.
So like this, there is one more sequence is there. One more sequence is there. So I want to demonstrate that. What is that sequence? Is same, sir. Instead of a fib, we have to call it as Fibonacci sequence. Fibonacci sequence. So Fibonacci means what? I told it is a sum of previous two digits. So Fibonacci means sum of previous three digits. But first digit is 0, second digit is 1, third digit is a 2. If you add these three, what is the result? 3. If you add next previous 3, 1 plus 2, 3, 3 plus 3, 6. Next, 1 plus 2 plus 3, 5, 5 plus 6, 11. Next, 11 plus 6, 17, 17 plus 3, 20. Like we have, what is the formula? F of n minus 1, n minus 2, n minus 3. Sir, if n is equal to 4, my output is 6. If n is equal to 6, my output is 20. Sir, only thing is, instead of dividing 2 times, suppose if you take f of 4, instead of dividing 2 times, you have to divide 3 times. One is f of 3, another one is f of 2, next one is f of 1. We have to consider first 3. So whenever 2 is coming, stop. Whenever 1 is coming, stop. This one, again 3, right? 3 minus 1, 2. 3 minus 2, 1. 3 minus 3, 0. Now how much values it will return? When 1 came, it will return 1. When 2 came, it will return 2. So here 2, here 1, here 0. 2 plus 1, 2 plus 0. It will return 3. 3 plus 2, 5 plus 1, 6. Correct? Are you clear with the theoretical approach?
Yes, sir.
Any doubt? Now, let us
No,
write
sir.
in the form of a program so that you will get clarity. So what is a program here is, in the place of a fib, I am taking trip. In the place of a fib, I am taking trip. What is the additional thing? So, or if n is equal to 2 also, we have to return. So trip of n minus 1, trip of n minus 2, trip of n minus 3. Now observe. Sir, is the Fibonacci sequence came or not? Anyone? Can you please cross check? Anyone please cross check?
Yes, sir, is right.
So this is nothing but how we can calculate nth Fibonacci sequence. If you are clear, then I will move to the next program. Can I?
Mm, definitely, sir.
So the next program, what we have here is, so I want to convert the given number, convert the given number from decimal to binary. I want to convert the given number from decimal to binary. So how we can do? First of all, we have to understand what is mean by decimal, how you are going to convert it into binary. Suppose if you take n is equal to 7. Sir, what is the binary equivalent of this? Binary equivalent will become triple one. Suppose if you take n is equal to 9. What is the binary equivalent of this? Sir, 100. If you take n is equal to 12. What is the binary equivalent of this? 1100. Like that we have. Okay, so I have taken a number. I am trying to convert that number into binary. You know very well how to do that. So if you want, just let me give one example. If you take 9, first you have to divide with 2. Sir, 2 fours are 8. What is the remainder? 1. Next 2. Sir, 2 twos are 4. What is the remainder? 0. Next 2. 2 ones are 2. Remainder is 0. Sir, if you write in the reverse direction, 1001 is nothing but a binary equivalent for this given number. Clear, everyone?
Yes, sir.
Now we need to write an algorithm to calculate this. Okay?
Okay, sir.
Right. Sir, clear. Can I go for a program? So first I will draw state space tree. Please listen carefully. I am calling a binary function by passing the number called 9. So what I will do is I am going to write a formula where it will fetch the remainder value. What is the remainder? 1 plus I will do the same process for 9 by 2. What is 9 by 2? 4. What is this formula? Can I say n percentage with which number you are dividing? This is the
2.
first formula. Now again, what I am doing? Sir, b of 4 I am taking, right? This one we should not take directly. Why? Because these numbers we are not adding. If you see 1 plus 0 plus 0 plus 1, we are not doing. We are adding by multiplying with 10. So because unit positions, tens position like that. What about B of 4? Sir, 4 percentage 2, which is nothing but 0, plus 10 into, so 4 by 2, which will become 2. I captured this 0 and then 2. Next, for this 2 again, so 0 plus 10 into, so B of 1. These two I captured. Now, B of 1 will become what? So B of 1 will become 1 into 1 plus, so 10 into B of 0. So whenever 0 came, I request everyone to please be on mute. Ranjan Kumar, please be on mute. So whenever 0 came, it will return 0. So 10 into 0 will become 0. 0 plus 1 will become 1. Now 10 into 1 will become 10. 10 plus 0, it will become 10. 10 into 10, 100. 100 plus 0, it will become 100. So 100 plus 10, 100 into 10, 1000. 1000 plus 1, it is going to return 1001. Is it our required binary number or not? Yes. Clear, everyone?
Sir, why we have multiplied with 10, sir?
Because see here, you are seeing the numbers we are taking as it is, right? We are not doing any operation. So this 1 is there at a unit position. It is there at a tens. It is there at a 100 position. It is there at a thousands position. Sir, if you see every time multiplied with a 10, right? That's why. Okay. Clear.
Yes, sir.
So now let us write a program to meet this requirement. What I will do? So we have to take a function like a static integer. What is a method name that you have to take? Let it be binary. which will receive a number n. So if the number is equal to 0, we will return 0. Otherwise, we are going to return n percentage 2. Why we are dividing with 2? Because we are dealing with the binary. 10 into binary of n by 2 I am taking. That's all. Let us print a number followed by tab space, then bin of that number. So it will print the numbers from 0 to 20. It will print their binary equivalents. Are you seeing? Better, I will take print ln so that line by line we can see. Are you seeing 0 to 10? Every decimal number corresponding binary numbers we are getting. Clear? Any questions? Clear?
Yes, sir.
Right. Next, I want to take the same program, but this time I don't want to convert to binary. So I want to convert decimal to octal. So what is the base of octal? We have to write code for OCT. OCT means what? Octal. So how you can convert? Sir, n percentage 2 is there, right? Here I am taking n percentage 8. Here also I am taking n percentage 8. Why? Because, sir, what is the base of octal number? Octal number base is nothing but what? 8, right? That's why I am dividing with 8. Now let us run the code. So decimal numbers up to 7 same numbers will be there. But 8, 9 won't be there in octal, right? For that corresponding decimal numbers are coming. Like that we have. Clear everyone? Clear everyone?
Yes, sir.
Any doubt?
No, sir.
Right. So next application, I want to check whether the given array is already sorted or not. So I'm going to give one array. Is that array is already sorted or not? I want to check. Let me give some inputs and tell me is it already sorted or not. Sir, already sorted means it has to return true. If it is not sorted, it has to return false. Okay. Now, assume the data which I am taking here is 10, 20, okay, so 30, 40, and 50. Tell me, is the array is already sorted or not?
Yes.
My output should be true. Suppose if I am taking 10, 30, so 40, 20, 50. Is the array is already sorted? No.
No.
So we have to get false. You understood the problem statement, right? Please confirm.
Yes, sir.
Yes.
So how we will came to know? Just we have to compare. If we are comparing adjacent elements, if the first element is less than second element, we will continue the process. Here, is 10 is less than 20? Yes. Then continue. 20 is less than 30? Yes. Then continue. 30 is less than 40? Yes. Continue. 40 is less than 50? Yes. Continue. 50, is there anything to compare? No, you can stop. Sir, is 10 is less than 30? Yes. 30 is less than 40? Yes. 40 is less than 20? No. So here itself you can stop. No need to compare further. Like that we have. Sir, if you understood the logic, I will go for program directly. Clear?
Yes, sir.
Hmm. So let us take some examples here. So I will take some three arrays. Let me declare integer array A is equal to, I am taking 10, 20, so 30, 40, 50. Like this, we have an array A, and I am taking another array B is equal to, so 10, 30, 20, 40, 50. Okay. Then integer array C is equal to, so 10, 20, 30, 50, and then 40. So I will call a utility method, okay, named with is sorted. We will pass the array, and from which location we need to compare? From 0th location. My output is always a boolean value. So that what we have to implement? Sir, we need to take a static boolean method is sorted. It will take one array, okay, it will take one array A and index value also. So based on this, we have to run the code. If you are clear with the skeleton, then I will fulfill this code. Clear?
Yes, sir.
Yes, sir.
What is the first case? Sir, I will write the condition. Tell me, is it true or false? First, I am checking the value present at index is less than A of index plus 1. And tell me what we have to do. If this condition is satisfied, do we need to continue or we have to stop?
Yeah, we need to continue.
Can I write again return is sorted of same array but index plus 1? Am I right? Suppose if this condition is not satisfied, then which value we will return? False. Correct? Am I right?
Yes, sir.
And when we have to return true? When we have to return true? If all the elements comparison is completed. So how you can check? If index value is reached to length of the array minus 1, then I will return true. Am I right, friends?
Yes, sir.
Then automatically we will stop. Now let us run the program and check, is the expected output came or not? Please confirm.
Yes, sir.
This is the way how we can able to verify. Any queries up to this?
No, sir.
Right. So these are nothing but some applications what we have. Sir, tomorrow also we have a session, and tomorrow is the last demo session. We will cover some 6 applications on tomorrow's class. With that, demos are going to complete it. From Friday onwards, we will have the regular class. So the people who are willing to continue in this batch, you can start making the payments by today or tomorrow and continue the regular classes. Clear?
Yes, sir.
Yeah, right guys. Thank you.